to start this video out with just a reminder about graphing a rational function, and then we're going to graph 2 with this 7-step method. First, you look at symmetry by plugging in negative x algebraically. Second, you find the Y-intercept. Third, X-intercepts. Fourth, find any vertical asymptotes. 5, find any horizontal asymptotes. 6, plot one point between and beyond each x-intercept and vertical asymptote. And 7, use the information obtained previously to graph the function between and beyond vertical asymptotes. So we're going to graph this function 2x over x plus 2, and we'll try to go through these steps. So for our first thing was to look at symmetry algebraically. So we plug in negative x. So we have 2 times negative x over negative x plus 2. We clean it up, negative 2x over negative x plus 2. So we look to see, is that the same as the original? No, it's not. These are negative here. They were not on the original. So it is not symmetry to the y-axis or even. Is this the opposite of this one? So if we put a negative in front of this, that would make it the opposite. And then take the negative either with the numerator or denominator. So if we put the negative up here, it is not equal to that because this one is negative. If we put the negative down here, it would be negative x minus 2. So it is not either. So there is no symmetry. Right, y-intercept. So plug 0 into x. And this gives us 0 over 2, which is 0. And so 0, 0 is our y-intercept. X-intercepts. So we set the function, so set y equal to 0. Remember, you only have to use the numerator of this rational function because 0 over anything is 0. Divide by 2. And so you get x equals 0. All right, so our x-intercept is also 0, 0. This is kind of getting all over the place. I don't have a big enough screen. All right, vertical asymptotes. Remember, you look at your denominator, right? X plus 2. When is this equal to 0? When x equals negative 2. All right, so this one, x equals negative 2. That's our vertical asymptote. All right, horizontal asymptotes. You use your table, and your degree of your numerator is equal to the degree of the denominator. So you take the leading coefficients as a fraction, 2 over 1 or 2. And remember, this is y equals. Right, and then we will plug in some points and make a table. I am going to pull up your graphing calculator and get these points, but also you can see it there. And then we're still going to graph, but rather than just going through and plugging all these in, I mean, that would be your steps. Take your negative 4, plug it in. We'll do a couple. All right, so if we plug negative 4 in, 2 times negative 4 over negative 4 plus 2 is negative 8 over negative 2, which is positive 4. All right, and so that's how you would go through and get your table. All right, we're going to pull a graphing calculator, and I'm going to scoot it over. Right? One thing for these, when you enter a rational function, you have to put parentheses around the numerator and parentheses around the denominator. So if y equals, and I had one in here, so let's clear it. Right. So I want parentheses 2x, close parentheses. So I want that whole thing over the whole denominator. Now put the denominator in parentheses. X plus 2, close parentheses, enter graph. Okay, we can kind of see what our graph looks like. We're still going to graph it by hand. I'm just being lazy and I'm going to get the points out of here. So I'm going to do second table, right? And this -2, look, that's your value you threw away. You can't have -2 because that makes it undefined. That's why you're getting error here. All right, so what I wanted in my table was -3. Right, -3 is 6. You can write these down somewhere. When I start writing, it will take my calculator off. So -3 goes with 6. -1 goes with -2. 1 goes with 0.666. That is 2/3. 2 goes with 1. And my first one I did by hand. Let's verify and make sure I didn't make a math error. -4 goes with 4. All right, we'll graph it by hand and then we'll pull the calculator back up and make sure our picture looks right. Okay, so let's finish filling in these values and then I'll clear part of this stuff off. So -3, 6, -1, -2, 1, and I went ahead and changed that to 2/3, and 2, 1. All right, let's put our information on our grid. So the Y-intercept 0, 0, and that is the same as the X-intercept. A vertical asymptote at x equals -2. A horizontal asymptote at y equals 2. And then to plot some points. Now, you would not normally be given this. You would just be given this what to graph. So you would have to choose these. And the important thing is to get some in each section. So a -4, it's in this section between these two. -3 is also here. -1 is between your intercept and this asymptote. So that's a good choice there. 1 is on the other side of this intercept. And then 2 just gives us one more point. So that is why these particular points were picked. All right, let's put some on and see how it looks. So -4, 4. 1, 2, 3, 4. -3, 6. 1, 2, 3, 4, 5, 6. -1, -2. One and 2/3. And 2, 1. Right, and remember that it's going to go toward the asymptotes. So this will go this way, and this way, and this one will go this way. And now I'll pull back up our graphing calculator and see if our picture looks right. And it does. Notice you can see here, this one is going. There is your vertical asymptote. The calculator doesn't put the horizontal asymptotes on. And this is your other 1 through 0, 0. We'll do one more. So here is our function. And first we'll test for symmetry. And so we plug negative x into the x. And then we'll clean that up. So this gives us x squared plus x minus 2 over x squared minus 16. Right? Is that identical to the original? No, because this sign of this x is mixed up. So this one is no. All right, we want to know if it's the opposite of the original. So if we took a negative sign in front of the whole thing, if we distributed it through the numerator, right, that would give us negative x squared plus x plus 2 over, this one would not change, you only put it in the numerator or denominator, all right? And this is not the same. So this is the opposite of this one, and we did not get the opposite either. So it has no symmetry. But we did the step. All right. So Y-intercept, that means plug 0 into x. So f of 0. So we have 0 minus 0, and we get a negative 2 over 0 squared is going to be 0 minus 16 minus 16. This will reduce to 1/8, and the two negatives will give you positive. So positive 1/8. So this is 0, 1/8. That is your Y-intercept. For your X-intercept, we will set our function equal to 0. And we only have to set it to the numerator. This we would factor. And we can use 2 and 1. And you should always check, make sure you factor right. So x equal negative 1 and x equal 2. So our x-intercepts are going to be negative 1, 0, and 2, 0. Right, vertical asymptotes. You're looking at the denominator and you're setting it equal to 0. And solving, this is a difference of squares. So x equals negative 4 and x equals positive 4 are going to be vertical asymptotes. For the horizontal asymptote, we go back to our table and look at the degrees. The degree of the numerator is 2. The degree of the denominator is 2. They are equal. So your horizontal asymptote is going to be y equals the leading coefficient, which is 1 over 1. So y equals 1. And then we're going to get our points, and we'll do the same as we did with the other and use our calculator. We will plug in 1 point. So if we plug in the negative 5, so we have negative 5 squared minus a negative 5 minus 2 over negative 5 squared minus 16. So we're just plugging in. All right, this gives us 25 plus 5 minus 2 is 30. Minus 2 is 28 over. Negative 5 squared gives us 25. minus 16 would give us 9. And let's divide that out. We get like 3.111. So I'll just cut it off there. And now I'll pull up the calculator. So remember to enter your numerator and denominator with parentheses. So our numerator, we have x squared minus x minus 2 close parentheses divided by parentheses x squared minus 16 close parentheses. And we'll graph. Right, so that's what we should look like. Let's get our table. Second table. All right, and there's your -4 with an error because you're not allowed to have a -4. That's an excluded value. All right, -2, it's going to be -0.333, which is -1/3. And I will have to write those in a minute. You can write them. 0, you get 0.125. This is 1/8, which we found earlier. It is one of the intercepts, the Y-intercept. All right, 3, we get -0.57. So a little bit more than -1/2. And then 6, 1.4. Right? So I'll fill those in, and then we will put things on a grid. So we'll start with our Y-intercept. Over 0, up an 8, so it's just up a tiny bit. -1, 0. And 2, 0. This one's up a tiny bit higher than those. Right, we're going to have a vertical asymptote at -4. X equals -4. And we're going to have a vertical asymptote at x equals +4. We're going to have a horizontal asymptote at y equals 1. All right, and so there you have your 3, you actually have 6 sections. And so then we'll put our points on, but let's see, why did we pick these points? So why were we given -5? Well, -5 gives you a point in this section to test whether it's going to be down here or up here. Right? -2 is in this section. It is between this intercept and this vertical asymptote. The 0, 1, 0.1/8 was between these two, but we had already actually found it as an intercept. 3 was between this intercept and this vertical asymptote. And 6 was just giving something out in this section. So you have to have something in each section. All right, and let's switch to blue. So -5, I'm going to change my mind. We'll go back to red to put the points on, and then we'll use blue to connect. All right, so -5 and 3.1. So 1, 2, 3, and tiny bit. So it's going to be up in that piece, and it'll go toward the asymptotes. Right? -2, and it's -0.33. So about a -1/3. It's about right there. 0.1/8 is actually on our graph. 3 and -0.57. So a little bit more negative than a half. So it's about right there. And 6 1.4. So there's 1, so not quite a half. So that one is going to be up in this region. So now they are going to go toward the asymptotes. So this one will go this way and this way. In this section, you're going to go toward this asymptote and this way. And this section is going to go this way and this way. So I just wanted to pull our graphing calculator back up so that you can see that our graphs look alike.